like to explain you where is circuit theory. It seems a bit peculiar to say where is circuit theory, but there is a relation between circuit theory and understanding the nature. So we can consider circuit theory as part of the understanding the nature. How does this happen? Let's start with the first frame. There is a science on the right hand side, and there is a world on the left hand side. In this world is in the cosmos. World is in this cosmos. From time to time we call it nature. And nature is full of materials. There are living creatures on it. Human is part of these living creatures, and these human creatures introduces some devices and equipments on the world. So if we go to the nature, when we examine the nature, we can observe some events running around us. Some of these events related to electricity and magnetism as part of the events of nature. We do observe them. After the observation, we could do some experiments and find out the laws of the nature. So that means you do many experiments, and if you look at the common part of these experiments, you might introduce some rules, laws in practice. For example, we know what magnetism is because there is a equipment which shows North Pole for the ships. So that's magnetism. Electricity or thunderbirds between the clouds. There is an electricity. We do observe that. These are our observations. From these observations, we do the experiments and find out some laws ruling all of these observations. So the human activities, these experiments done by the humans, and these human being introduces some devices and equipments to facilitate that human life on the world. That is the world sign. So if you move with the signs, people in this environment, they would like to say something about the world on the paper. How they could do that? Use the science. Science introduces theories, and theories in general might say that are the modeling of the physical events in the nature. So as a part of science, we end up with the electromagnetic theory. What is it? Go inside that. Electromagnetic theory, the fundamental tools is mathematics. It uses calculus, linear algebra, differential equation, Boolean algebra. These are all these tools, and we are lucky that the technology has developed such fast way that there are some computer-aided tools, MATLAB, Proteus, and many others are many tools that we could use to facilitate our life in the calculation that we do by using these tools. That means mathematical tools. Now this theory starts with the axioms. Whatever we said in the nature in here as laws, the laws becomes the axioms of the theory. Axioms are the proposition which has been accepted as true without any mathematical proof. But there is a physical proof. Whatever says in the axioms can be observed in this physical world. Otherwise, it cannot be an axiom. But when you accept these axioms true in mathematical theory, that is the electromagnetic theory, then we introduce theorems, we've got to prove those theorems by using the axioms or some other already proved theorems. And then we do the synthesis, realization, and design business. That means if you've got a electric signal, electromagnetic signal available to you, but this is not the way that you see it, and you've got to transfer it to another signal. How does this happen? For example, if you consider a TV equipment, the input is electromagnetic wave, which is available in the air. Many of the TV channels information is available there, but we cannot see those in the air. So we've got to transfer this electromagnetic signal to another signal, which is still electrical, that we could observe. So that means that is TV equipment. Transfers the available information to an information that could be observed by human being. So this is also the purpose of TV equipment. So if you consider that input signal is available and output signal is known, how are you going to design a circuit or a machine or equipment which transfer that input to that output? That means design this TV. By saying design, we are saying which elements are going to be connected how to transfer this input signal to the output signal. That is the realization. So we could do this by using this theory, and that mathematics could do the synthesis. That means make the decision about the type of the elements and how to connect them together. But this cannot be done in this world that we are living in. That means you can't do the synthesis without any mathematics. Why is that? No mathematics, no design. What we are saying is this: we cannot introduce a TV equipment in the lab by connecting the elements, randomly chosen elements, randomly connected. We cannot find out with TV. Most probably we are going to die before we find a TV. Therefore, the mathematics is important, and it is the basic or fundamental base of electrical engineering. Therefore, it is important. Some students stating that mathematics, why do you need that mathematics in engineering? So that is the answer to those students. I would like to say one more thing about the world around us and the science. In the lab in the world, we do the experiments and measure some of the quantities, electrical quantities. That's measurement. In the science side, in theory, by using pen and pencil and paper, do the calculation, find some quantities, electrical quantities. So these measurement quantities and calculated quantities match to each other. Under they match to each other, we could say that this science explains the world around us. So the second part that we are going to examine now we found a relation now between the world around us and the science. So science, part of the science is electromagnetic theory. So if you consider the whole science, natural science, physicals, chemistry, social science, so science is a global science, but we are just dealing with part of it, which is electromagnetic theory as science. So how we are going to learn this science with this electrical engineering department program? So to learn that, there is a program. So you are a student in that program. So what you are facing in that program, electronic engineering department, there is a program, and there are some staff, academics, which run that program. The academics, there are some of them full-time, part-time, some other academics from the other departments, and there are some academics coming, external academics coming from the other universities. So these are your teachers. Your teachers teaches the courses inside that program. So when you come to that program, before you design a program, there are some information that you got to set first. This is called, one of them is called program objectives. And there is program outcomes. And then if you go a bit in, learning outcomes, program outcomes relations. So the final aim are program objectives. These objectives, if we go inside, this here, if you read this, the Electronic Engineering Department committed to advance, transmit, and sustain the knowledge of engineering to have a position and progressive input to the local, national, and international community. The department, with state-of-art art facilities, will provide students with a set of educational programs in electronic engineering relevant to local and national industrial needs, utilizing the latest in educational technology and teaching techniques. So this is our aim. So how we are going to reach to that aim? We've got to reach the program outcomes first. These program outcomes are set by, in the world, is by ABET. This is Board of Engineering and Technology, American Board of Engineering and Technology. YÖK is the Turkish University Association, and MÜDEK is just Engineering Association. This is a non-governmental organization. These program outcomes are common for all engineers. This is also the part of student survey. That means we are designing a survey for students, asking whether they reach these program outcomes or not. They reached at them or not. So let me to read some of the program outputs. What are they? So these are the capabilities each engineer should have when they graduate. An ability to apply knowledge of mathematics, science, and engineering, an ability to design and conduct experiments as well as analyze and interpret data, ability to design a system realistic constraints such as economic, environmental, social, political, ethical, health and safety, manufacturability, and sustainability. So there are many constraints to do the design while you are doing engineering design. Ability to function in multidisciplinary teams, identify, formulate, and solve engineering problems, understanding of professional and ethical responsibility, ability to communicate effectively, and it goes like that. Altogether, there are 11 of them. These are important capabilities that an engineer must have when they graduate from that program. So this should also be your aim. So how we are going to reach to that aim? We are offering you a program, course groups. So we can, learning outcomes, subjects to be taught, 5 to 10 for each course. I will explain this later. So if you look at these course groups, there are some groups. Program has got some sub-programs in it. Core courses, service courses, elective courses, laboratory courses, and service courses. So what is the core courses? The main courses. So for example, circuit theory, introduction to electric circuits, circuit theory, these are those two courses that I will be teaching, and logic circuits. So these are the main courses, compulsory courses, let's say. Service courses are the science courses, and calculus, physics, linear algebra, mathematics, physics, differential equations, numeric analysis, introduction to electromagnetism. This is a mathematics course. Random variables. These are the background information that we need in order to understand these courses. Elective courses, those are the courses which is where you're going to take it in the fourth year. So in the fourth year, all the courses are selective courses, and these are the course subjects that you can select from. Laboratory courses, some of the compulsory courses have laboratory sessions, but these laboratory sessions is not considered as part of the course. These are separate courses. For example, Introduction to Electric Circuit, there is a circuit lab here, but this is an independent course. Why is that? Because we are saying that we pay more attention in practice as much as theory. So there are some lab sessions here. Altogether there are 6 lab courses in our program. And service courses, these are the compulsory courses that should be taken by the students, bachelor students in Turkey. So these are compulsory courses. So this program, what we are saying, if you take these programs, you're going to end up with these capabilities. That means when you take these programs, you're going to have these capabilities and graduate. So there is a table here, if we go inside. For each course, you're going to see here a matrix. It is called course assessment matrix. On the left side here are the subject that we're going to teach you within a course. For example, this is EE 2201 is a course in our program. In this course, these are the subjects to be taught to the students, and that matrix relation on the columns of that matrix. So these are called learning outcomes. This left-hand side, rows represented by rows of the matrix, and the columns of the matrix are the program outcomes that we said here. We said aim. So these are the program outputs. There are 11 of them. These 11 program outcomes are in these columns of this matrix. So this matrix tells that the first learning outcome in this course affects the program output 1, first one A, at the level of 3. For example, this learning outcome within this course, the subject that we are going to teach you, contribute to the 1, 2, 3, 4, 5, 6, 7, 8 program output as a low level. So that is the highest level 3, medium level 2, and the lowest level 1. So if you look at the whole course, we could say that when you take this course, not the all courses, but this course, by these learning outcomes, contribute to 1, 2, 3, 4, 5 program outcomes of this program. How the range of that contribution is explained, are explained by these numbers. So what happens, this course contributes to have the capabilities we already set to you. So there is another matrix here. It is called program assessment matrix. On the rows here, you could say just one course and which program outputs it is affected. So red is the highest level, black is the medium level, and the gray is the low level contribution. So this is how the system works. If you see the whole system once more, this program, in order to help you to understand the world, helps you to do that, to understand the world. By this program, you're going to get these capabilities. These capabilities is going to help you to understand the world around you through the tool of that science modeling. So within this program, let's come to our circuit theory. As I said here, there is these are the core courses. It is Introduction to Electric Circuit and Circuit Analysis. So you're going to see this within that program. It is related to electromagnetic field theory. It is this is the general subject. That means this program aimed this theory. This theory has got distributed elements. It is axioms or Maxwell equations. Independent variables are time and the position variables x, y, z. And it uses multiple functions and partial differential equations, since the independent variables are 4, not 1. So as part of these electromagnetic field theory, we've got the circuit theory. Circuit theory is a special case of electromagnetic field theory, and these are distributed elements. And here is lumped elements. That means the elements are not the wide type. Antenna, for example, is a distributed element, but a resistor is a looped element. So in circuit theory, in my courses, we will be using that lumped elements. And the axioms of this theory is called Kirchhoff current and the voltage law axioms, KVL and KGL. Independent variable here is just 1. Since we've got 4 here, we've got just 1. And the mathematical tools that we're going to use, linear algebra, ordinary differential equations. So the course names, electric circuits, circuit analysis and logic design. And these courses are the prerequisite courses for the signals and system, electronic circuits 1 and 2, and the control systems. So this is where the circuit theory is in your understanding of the world through science. That is the full point of it.